Okay. First of all, the derivation of load flow equation. Before we draw the diagram for it. In this place, we are having SG1, SG1 here. We have our admittance S1, and from here we are having IS1, and from here we are having IL1, and here we are having what we know as SL1. Then from there we stretch. We have an impedance here, impedance of 12. At this point here, we have what we call V1 at V1. Here we are having a current known as I1 or IG1. IG1. Then here we are having a current known as I12. From here again, we have something similar to this. Okay, we have impedance first, just like opposite of this, and again we have the current IL2, and here is SL2, here is YS2, here is IS2, here also have a voltage known as SG2. From this point here, our I is 12 and IG1. Then at this point here, we have V2 and V2. Okay? Now, having this expression on the board, we can now have an expression known as reactant power to be equals to V1. Okay, so from here we can say our I is equals to reactance over velocity. That is where we can now look for IG1. Since we know this one, we'll say IG1 is equals to IG1 feed I12, and we also feed IL, and also feed IS1. So IG1 is equals to I12 plus IS1 plus IL1. So from this expression, I12 is going from voltage 1 to voltage 2, and it's passing through admittance known as Z12. Now, if you can recall in Ohm's law, we said I is equals to V over R. Same thing we are going to do here. We're going to say I12 going from here to this place will be equal to V1 minus V2 over the impedance is passing through, which is what? Z12. Okay? Plus IS1. This is IS1 coming from V1 to YS1. But in this place, we're not going to say V1 over YS1, rather we'll say V1 YS1 plus IL1. Remember IL1, we say IL1 is equals to IL1 is equals to S over S1 L1 over V1. So SL1. Okay, from here, look at this IG1. Our IG1 is going like this. So IG1 will be, it's coming from this place, going to this place. It's coming at this node. Okay, at this node, we say it's going to be IG1 over what? Over V1. This IG1 over what? Over V1. So, from there, if I take this to this place, it becomes SG1 over V1. Then taking this to that place, we change the sign from positive to what? To negative. SL1 over V1. asterisk is equals to, so at this point we are having b1 minus b2, b1 minus b2 into bracket. Now we are having here to be what? Plus, I'm coming to this one, let me give a space, plus b1 y s1. Now let's look at this. At this point, I think we just stay at this stable point so that, wow. Okay, at this point, this z12 will go up so that you grind with this ys1. It will now become something like y12 plus this. Okay, since we know that we'll take the LCM of this, the LCM of this is v1. So v1 over v1 divided by v1 will give us 1. 1 times sg1 is sg1 minus v1 divided by v1 is 1. 1 times sl is also 1. Then is equals to v1 minus v2. Okay, y12 plus v1 ys1. Okay, from here, this will cross multiply this v1, use it to cross multiply. Use this v1 to multiply this, use to multiply this, use to multiply this to all two. So now v1 times v1 will give us v1 asterisk this v1 here. Okay, and this y12 times this v1 will give us y12 minus v1 times v2 give us v1 v2, y12 times this will give us y12 plus this v1 multiplied by this v1. You have to write v1 asterisk and you have the v1 and ys1. So from this point here, we have v1 here, v2. So we will now make use of when sg1 minus sl1 is equals to asterisk s. So at this point here, there's a conjugate here. At this conjugate here, which we omitted. So v1 conjugate. So v1 times this v1 here, that makes us conjugate here and v1. Conjugate here also. And also conjugate here. That is the reason why we are having conjugate there, because this is conjugate. Even this one too again is what? Conjugate. Which gave us conjugate. Will be equals to, and this place will be v1, then e, due to the asterisk it will be minus j d1 attached to this, then v times or times v1, then e. Then instead of minus, because there's no asterisk here, just write j d1 times y12 e alpha j conjugate alpha 12 minus v1 here, which is going to be like this, e minus j alpha d1, v2 will be e j d2 times y12 e j alpha 12, then plus v1, and this v1 will look same like this, then multiply by v1 e j d1, then y s1 is e j alpha s1. At this point here, this e minus j d1 and plus e j d1 will cancel each other. This side too will cancel. No. This will not cancel. Okay, this will also cancel this place. So v1 times v1 will give us v1 squared. Bring down your y12. Then we have e j d12 minus. Then this one will be v1, v2, and y2. Then y12. I do there. Then e j into bracket. Now we have minus d1. I don't want to start with minus d1. I want to start with d2 first. So I'll put here d2 then minus d1. If you multiply this back, you have this back. So plus alpha 12. This alpha, not d. Alpha 12. Anytime there is y, there is admittance. It is having alpha. Close the bracket. Plus this has cancelled this side. So b1 times b1. b1, the b1 did not cancel. It is only the e minus j d1 and e j d1. They are cancelled each other. Because here is minus, there is plus. They cancel each other. They have b1 times b1 giving us b1 squared. Then y s1 e j alpha s1. When one s as sterical, e j theta is equals to cos theta plus j sin theta. And when it's having minus, j theta, it will be equals to cos theta minus j sin theta. But here I think all is having positive numbers. So we have from here v1 square y12, then e, instead of e j d12, we have cos d12 plus j sin d12. Okay, minus v1 v2 y12, then we come here cos into bracket d2 minus d1 plus alpha 12 plus j sin the same thing, d2 minus d1 plus alpha 12. So from here we will now say that where s is equals to p minus j q. So anywhere you see cos, it is for p. Anytime you see q, it is for what? For sine. S equals to p minus j q, where p is representing the cos and q is representing the sine. So here we say p is equals to, now we're going to be having v1 or v1, then we will have, after that v1 we will have y, this i, this i, vi, so ik. So all those 12 will be representing, k will be only the 2, just like 1, 2. K represent 2, I represent 1. So where v1 we have vi, and y12 we have yik. So yik is summation to the natural number where I is equals to 1. Now at this point here, we have into cos of into brackets. Now we're going to be having b k minus I plus alpha I k. So this is our answer for B. Similarly, I know that you know why this page is di now, because this page is 1. And this page is what? Is 2. This page is what? 1, 2, d12, alpha 12. So where I is equals to 1, k is equals to 2. Similarly, for q2, say q is equals to the same thing, vi, yik, summation of natural numbers when I is equals to what? 1, then cos sine into bracket dk minus d1 plus alpha I k, di I k.